Hello and welcome to This Month in Security. I'm your host, Aubrey King with DevCentral, and joining me this month, we've got Aaron Brailsford.
And you are reliant on whoever produced the firmware the motherboard is running, basically.
Malcolm Heath.
Even in those days, I was told very clearly and very repeatedly, email is not reliable and it is not immediate.
Jen Carlson.
This is a way for us to work beyond higher education to try and fill the talent.
And Jason Ross.
And we just walk them through, like, this is what a day in the life of the consultant is. This is how we do it.
This month, we'll be talking about cybersecurity apprenticeships and large language model security. So strap on those earbuds and get ready for This Month in Security. So this month in security was an interesting one that actually saw me join the OWASP Top 10 for Large Language Models. I've been inspired by some of the things we've talked about on this podcast over the past several months, and after a conversation with an old colleague of mine, Jason Ross, I decided to actually give it a shot, pitch in, lend a hand, and do something good for another community, the security community. We'll be talking a little bit about large language models and what that is with Aaron Brailsford and Malcolm Heath, of course. But first, we're going to talk to Jason Ross and hear a little bit about apprenticeship at the Rochester Institute of Technology here in Rochester, New York.
I guess just to start it, what I currently do with RIT, I'm technically an adjunct faculty member. And so when I tell people that, they automatically think, oh, you're a professor, you're teaching. And yes, I'm teaching, but not in a typical classroom setting. So I'm not sure exactly how this came about, but as RIT was looking at the industry and the need, and there's the massive need for people, right? There's just such a shortage of people. One of the things that stuck out was while there is currently a path to career that starts in school, which wasn't there when you and I started out in this field, right? It was very much just kind of hands-on. You teach yourself, you find other people that are enthusiastic and share what you're learning. And it was this groundswell movement with security. Now there's clear-cut educational paths, and it's just a typical job at this point. But there's a lot of people that see that there's this cool career field that is interesting, and they don't know how to transition from what they're currently doing, whether that's sales or trade work or whatever, right? COVID kind of killed a lot of people's employment. A lot of people got laid off. And so they were like, well, what can we do? Security is kind of cool. We can do that remotely. What's our transition path? And so RIT, and I think other schools as well, but RIT is obviously the one I'm most familiar with, kind of built this program to address that need. So what they currently have is a cyber boot camp, which I'm not specifically involved in that, but there's a cyber boot camp program that is tailored towards really, really quickly getting people up to speed on both IT and specifically security. So you don't even have to have an IT background. It's just, hey, I want to transition. I want to do something cool and new. And then the way that's structured is basically it's a fictitious company, and they hire you as a help desk representative, and you go through and do what a typical help desk rep would, right? You answer fictitious support calls, and then you transition over a period of time to being on the other side of that, which is the network techs that get the help desk calls, right? So, hey, I'm having problems with my network. Now you're the network technician and you have to fix the problem. And then slowly over time, that transitions to you're the security staff that are working on securing that network. People that graduate that program have an opportunity to apply for a cyber apprenticeship. And that's where I come in. So we've done it once. It was a pilot program that RIT got a grant to specifically look at how this might work. And the intent was to provide an apprenticeship for people to get into cybersecurity. And the way that we structured it for that was basically I ran it as a pen test consultant shop. So we had 6 people that we accepted into the program. A key attribute that we were looking to accomplish with this was to make sure that we were hiring a diverse workforce for this. So we had I think 80% minority was our criteria that we set for ourselves. We ended up hiring 6 people, and 4 of them were deaf. That helped easily meet our metric that we were looking for. And it was really, really cool just working with that diverse community. It was definitely something new for me to have that kind of interaction. And we just walked them through, like, this is what a day in the life of the consultant is. This is how we do it. And then we actually got work for local companies and did actual pen testing with them. So at the end of this, they're able to go out and have real world experience that they can show on their resume and point to things that they've done that allows them to get a cooler job, hopefully.
I think it's really cool that neurodiversity is something that is really being talked about today as well. I think there's a lot of diversity that you can see with the naked eye, and it's hard, I think, for people sometimes to remember, oh, yeah, neurodiversity is something that we want to focus on as well. So these people who graduate from the apprenticeship, they've already got hands-on at real companies. So it's not like the boot camp where you're going through fictitious. There's real world hands-on with that. That's really cool.
Yeah, we've got a partnership with a couple different people. Eaton is a power company in the northeastern US, I guess. And so RIT, the ESL Cybersecurity Lab, so the SAFE Lab, we have a partnership with Eaton. So some of that work comes through that. We helped have the apprentices help out on some of those projects. And then we just offer to the community locally the ability to have pen testing done for things like nonprofits or schools or small businesses, medium-sized businesses that typically can't afford to hire security firms.
It still need it.
Yeah, exactly. They definitely still need it. And it provides a nice opportunity, right? It's a nice trade-off. They get some work done for them, and then we get the opportunity to ramp up people in the field.
That's cool that they've got some veteran tutelage too, man. I know you've been through pretty much everything in the past, being on both sides of the fence, red team and blue team. So one of our behind-the-scenes DevCentral cast members asked me, what about how some companies are doing apprenticeships out there for maybe not necessarily college students, but people who may have seen a change in employment status and still are looking for a modern day trade or apprenticeship in cybersecurity. I had the chance to talk to Jen Carlson from Apprenti to find out exactly what that looks like, as well, developing a unique path for people to transfer skills and learn a new career. Check it out. What is an apprenticeship in cybersecurity? What does that look like?
So for us at Apprenti, the intent is that we're pulling people from non-traditional backgrounds and reskilling them into technology roles. And in case of a cyber role, they're going to get pen testing and they're going to learn ethical hacking and go through all of those kinds of training mechanisms so that they can do threat assessment, and they will do a combination of accelerated classroom, and then a company is sponsoring them like F5 to come in and work for a minimum of a year as an apprentice, where they're paid basically a training wage. They're paid to learn and do the work at the same time to grow into the job. This is a way for us to work beyond higher education to try and fill the talent gap, since there's not enough talent being produced at the higher ed level for us to consume.
That's one thing I kind of wondered about. Who is this program designed to support, I guess?
So it's an 18 and over program. So we may end up with youth, much like your college crowd would be, but these are not college focused. This is anybody looking to career transition. And so the youngest I've placed is 18, eldest is 65. So there's no age limit. And the median age in my program is 32. And so more than half of them don't have a college degree, and none of them have experience in tech. They're coming in and saying, I'm at a point where I've maybe been underemployed. My number one career track is people coming out of the military. My number two is Uber driver. People who are like I've been doing this long enough and I can make a living, but I'm eking one out. And I now need to get serious about a career, but maybe college wasn't for me for whatever reason, socioeconomically, timing. And so this is a way for companies and government are paying for the tuition. So it's no cost to the individual. And then they're applying because they've got interest in basic skills that they think can be applied here.
You mentioned basic skills. So does this process start with like, what are your translatable skills? What is the sum of what you've done so far? And is every person's path unique because of this?
Very unique. Yes. I mean, I've got a couple of people that I sadly, they're both in food service, but radically different. I've got a guy who came out of the military who was MOS KP kitchen, right? And so he thinks he's going to go be a restaurant manager, and that's what he's going to do after the military. And then he applies to this program to see if he can get in. And we start talking about skill sets, not about what you actually did. Well, it turns out, even though his MOS was in kitchen, he was actually the head of like Afghanistan food supply and had to do supply chain demand, distribution, consumption calculations, spoilage calculations. Like he had to keep all of that running for battalions, right? And it's like, oh no, you're not going to be no. And so now he's in supply chain at Microsoft, like making six figures and not $40,000 a year as a restaurant manager, right? Like those are great skill sets. But at the other end of the spectrum, I've got a person who came in that if he applied for a job saying he wanted to get into technology, it would never have made it through the front door. But when we're skill set assessing, this person came in having been a Burger King manager. And this is now, I'm looking at skill sets. Again, take away the where. And he does hiring, payroll, consumption and food ordering, supply chain management, scheduling, and is multilingual. Well, all of those things to a company look really appetizing. And so it's a hybrid of like, how do we match? I kind of call this jokingly eHarmony for tech. Like, how do we take your skill sets, de-identify how and where you got them, go to a company and work with the company on how to identify and assess talent differently, right? This is not about pedigree, it's about competency. We're finding more and more companies getting into this skill set mentality and being willing to shift the paradigm away from where did you go to school and where have you worked?
That's really fascinating. It should be clear to anyone who's watched our show when you talk about supply chain. If you're out there and watch the show frequently, we talk a lot about supply chain security. So if you've got work in any sort of supply chain, understand that is translatable to security for sure.
Right.
So as far as this program goes in the future, how do you see this evolving maybe over the next 10, 15 years? Is there sort of a plan to take the cybersecurity portion further than it is, or to change it, or does it just stay sort of amorphous as it seems to be now?
Nothing in this country moves quickly. It's not a light switch. The government has been really focused on this, good or bad, for 8 or 9 years about shifting this conversation from what we grew up knowing as apprenticeship and the building and construction trades. Europe and Asia has been doing in every occupation imaginable for 80 years. We're a little bit behind the times in the US, and the government has been pumping money into stimulating this idea that apprenticeship can funnel into virtually every job class. For the US is no different than Europe. 70% of the people in this country don't go to university. That is not a preferred track. But in Europe, most of that 70% that doesn't go to university goes to an apprenticeship. Pick an industry, any industry, not only vet tech and culinary science or art. They go through apprenticeship for technology and banking and everything else, not just the trades. That's what we're trying to stimulate in this country. And what Apprenti is doing is obviously very specifically in cyber and high tech, but there are other programs like that for other industries, and the government is trying to proliferate this. And so the intent here is that in the next 15, 20 years, we get companies through this psychological change, society thinking differently, that it's not just blue collar, and that we create these opportunities for people to take an alternative pathway into these great careers and create more talent domestically for ourselves to consume. It'll get there. It's just going to take time.
I'm really enthused by this whole concept of apprenticeship. I mean, we've seen, especially with the pandemic, a lot of people that sort of had a stopgap or some sort of interruption in career. I mean, a lot of people had that sort of thing happen. It's great to see that there is a way for people to kind of catch back up and get into the swing of things and what they want to do in a controlled fashion.
I think it's starting to get momentum in both sides. I think we're starting to see it's less of a pushing the boulder uphill that it was 5 years ago.
Before diving into the industry happenings over the past month, I wanted to share a little bit of my conversation with Jason Ross regarding the OWASP Top 10 for Large Language Models. Now, another thing that I saw that you were involved in that I've been kind of drooling at is the OWASP Top 10 for Large Language Models. I think there are a lot of people who don't know what that is. I'm curious, what got you interested in that in specific?
My current employer is Salesforce, and they're super hot on AI. Like, we have our own AI, we have our own large language models. And so a lot of my day to day right now is interacting with applications that are being developed on top of LLMs or applications that are implementing LLMs for our customers. So recently OWASP put together this working group to do top 10 security risks for large language models. And it just seemed like a natural fit to get involved in that and provide, here's what I'm seeing is part of my day to day.
That's one thing that in this month in security, we've been talking nonstop about AI. At RSA, it also dominated conversation landscape this year. That was the hot topic, of course. And I think we're all going to need to deal with securing these things. Some of the things that we talk about, being able to kind of poison what an AI learns ahead of time and things like that, that's tremendously dangerous. And I think as an attack surface, it needs a lot of attention. When I saw that this was put together, it was kind of like, holy cow, it's good that we're getting ahead of this thing and that it's already in beta steps. Have they begun meetings at this point?
Yeah, we've had 4 meetings thus far. 0.5 of the draft is out. 0.9 is coming out next week, I believe, is the target. And then we're getting ready. We're doing 2-week sprints. So a couple weeks after that, we'll have version 1.0 out. It's really scary from a security point of view. It's exciting, but there's some really interesting, unique challenges that are very different from other application security risks.
And now I'll chat with Aaron and Malcolm about all the happenings over the past month with a heavy dose of LLM news.
Yeah, the chat IDS thing was in Koichi's This Week in Security. That was the first of several things that my entire team and more have written on large language models on DevCentral. And it got me looking at everything that people have written about large language models on DevCentral in the last month. We had Chat IDS, which the thrust of was literally you will need to hire less expensive security engineers because Chat IDS will explain what is good and what is bad in your IDS logs. Jordan wrote a nice article on securing generative AI. So this is like a 5,000 foot overview, I guess. It's not specific to any one deployment, right? But it's talking about the key things that you're going to need to secure if you're going to run a generative AI system. So like securing the infrastructure from attack, securing the training data from, against being poisoned, securing the model themselves, right? Because that's essentially a supply chain attack, and securing the outcomes, making sure you don't leak information and stuff like that. There are some big problems in that list that need careful consideration.
I love how he broke down just the elements of securing any of these LLMs just so succinctly. Here are the assets, the threats, the mitigations, and then what are the critical assets? What are the existing threats and what might be out there, as well as what do we have today that can mitigate some of the existing threats that are there now? And I mean, you look at this article, it explains the problem to people in very plain words.
Then we had an article about Worm GPT in Jordan's This Week in Security from the week of July 9th. Since that was written, we've had Fraud GPT written about in the last sort of week or two. You wrote, Aubrey, about generating spam GPT, generating spam with a large language model, and the fact that it will potentially let spam just blow straight through all of the filters.
When I worked for a top 20 mail provider, it was clear to me that my life as a mainly DNS admin prior to that, or LDAP admin also, I really didn't see what big email looked like and how much garbage is out there. And people don't realize how much junk is out there, how overbuilt internet routers are because of it. And really the only defense is how human is this thing that's coming at my mail service? How human is the text that it's sending me? And exchanging information with other providers as well through feedback loops. But that's all said and done, ChatGPT could blow that away. I think any AI would be able to make things that are human as far as emails are concerned. And that at that point, not only do you have this question of what can you trust, but all the filters and milters that are out there for SMTP resources are going to let all this mail through. And I really think it'll honestly, the problem will be filled hard disks. Having seen it, there's a lot of just data out there that's floating.
Even looking at what gets delivered right to my Gmail inbox, The spam outnumbers the real emails.
Yeah.
Hundreds of times to one, probably.
And then looking at WormGPT, what was written about this, I'm going, wow, it's already here. It's not, because in my article, I'm going, this is still maybe a little ways out. No, it's clear. It's like, it's here. It could happen.
Everything is a double-edged sword, isn't it? Really? This is just another example of it. The large language models, probably fantastic tools for understanding what's bad in your network, right? Like we talked about chat IDS. And I'm sure there'd be fantastic models for detecting spam. Also very good at creating it.
We're going to have to deploy more AI to combat the spam AI. And I don't know, that just, maybe there are better communication tools than email for organizations and interpersonally. I don't know. I remember in 2000 wondering, boy, is this SMTP thing worth keeping around? POP, IMAP, it's all very tough to secure, and the protocols themselves aren't really that great.
Like a lot of the fundamental protocols the internet is built on, they were built in a different time, right?
Oh.
Look at the amount of things we have had to bolt on to, or bolt into, essentially DNS to try and secure email, to verify the authenticity of a sender, to prevent emails being spoofed, to generate spam. All of that could have been resolved in the protocol when it was designed, but it was designed in a much more naive time. And I don't use that in a pejorative sense. It was a wonderful time.
I too was around back in those days. I want to challenge this. I don't think it was necessarily more naive. It was designed for an entirely different context that was academic, military, very small, with a community of operators that numbered at first in the tens, and then probably by the time I got involved, maybe in the hundreds. So everybody kind of knew each other. And if somebody started doing something bad, they literally could just disconnect, unpeer you, right? And nobody would have said a thing. Clearly, that does not scale super well. I mean, the protocol's designed in that context, so they figured there were probably defenses against bad actions, but they weren't baked into the protocol because of the context, I guess is what I'm trying to say. But that is a very, very different context than a global, worldwide internet with millions and millions and millions and millions of devices and servers and nodes and routers and all the other stuff that we have now. So
yeah, it was a much more controlled network at its inception, like you say.
And it was experimental too. Nobody was going to get super upset if something broke for a little while. I mean, when I first started using email, even in those days, I was told very clearly and very repeatedly, email is not reliable and it is not immediate. Those were just known things about how it was designed. So if you send an email and your buddy doesn't get it, don't come crying to me. Like, it'll get there eventually, probably.
When we got to like 2007, though, by that time, it was like email was expected in seconds. Like, I sent it. You get it?
Yeah.
You got it?
Yeah.
And it's funny. One of the things that when we talk about like these monolithic protocols that are kind of coming to the end of their usefulness, it's been fascinating for me to watch DNS over HTTPS or TLS, right? That's something that I think is really interesting. And I'll tell you, having deployed both DOH and DOT, it was very interesting to take a look at writing WAF policies to secure DNS objects. That to me is like fascinating. And I think about once we have SMTP over HTTPS and TLS, that I think will be a neat time, or we won't need SMTP, right? Maybe we just decide to pitch it.
It's interesting you say about protocols that are nearing the end of their useful life. These things have a habit of sticking around for a very long time, like fax machines, which are still yet to completely die, especially in the legal realm, right? They need a physical document with an actual signature on it, kind of thing. Certainly in the UK for many things. Actually, in the UK for many things, it can't even be faxed. It's got to be wet ink signatures. But you reminded me, saying about email that was not instant or guaranteed, of a story I read that goes back for a very long time. And maybe we can just put a link in the description here, but it was the 500-mile problem, which was basically they couldn't send an email more than 500 miles. And the problem was counted in distance, right? Not hops or anything else. We can put a link in it and folks can read it. It's an old story. So yeah, there's a lot to talk about LLMs. But it's not the only thing that's been happening right in the last month, even though it seems to be literally everywhere. There's been a ton of other interesting stuff. And one thing that caught my eye, and so I put it in This Week in Security, was the number of vulnerable FortiGate servers still exposed on the internet. We've talked before, and I'm sure we've talked before in this, about the difficulty of patching systems at scale, right? This was just another example of that. So CVE 2023-27997, assuming I didn't typo in that. Bishop Fox scanned the internet, and they found, I think it was 400 and something thousand FortiGate servers sitting on the internet, which that's expected that there would be many FortiGate servers on the internet, given what they do. However, 330,000 of them, as of the point they scanned, which I think was a couple of weeks ago, and the CVE goes back a number of weeks before that, still vulnerable to an unauthenticated remote code execution. That's pretty bad.
I can remember us covering that when that came out and thinking that that's months back. That is just scary. It's astounding to me that we can see 330,000 vulnerable still.
I'll chime in here with a little bit of maybe some insight based on the work that F5 Labs does. Some people who are listening to this may be aware of our Sensor Intel series that we publish regularly every month. And that looks at a lot of data that's essentially internet-wide scans hitting dumb sensors that we've got kind of all over the place. The funny thing about that is a not insignificant portion of the traffic that we see is companies like Bishop Fox and others, ranging from legitimate research firms to companies trying really hard to look like legitimate research firms, but absolutely are not, as well as just a whole bunch of random attackers. One of the things to bear in mind, and I'm not disputing that there are an awful lot of unpatched FortiGate servers out there, but there's probably some amount of those that are actually honeypots. And then the other thing to bear in mind too is that typically when people are scanning for these things, they take one of two approaches. They either are able to determine from a banner or some other behavioral thing what version it is, right? And that is, as I'm sure Aaron knows, given the fact that he used to work at F5 support, not always indicative of the actual problem being present. In other words, you may have applied a patch that didn't rev the version number, but still close the hole. I don't know for certain whether Fortinet's patching revved things properly in terms of banner detection or what have you. The other way to do it, and the more effective way to do it, but also the more dangerous way to do it, is to actually exercise the vulnerability. And we actually see, this is kind of interesting because we actually see some of these scanning entities do this. Some of them, obviously, they're really obviously hostile ones, actually do remote code execution and run a wget to download the second stage of their malware, and off we go to the races. Many of these actually do something that exercises the vulnerability, but will only, say, for example, cause a connection back to them that just says, essentially, yes, your code ran. A specific string gets HTTP posted back to some bit of their infrastructure, right? Something like that. That brings up a very interesting issue about the ethics of scanning for these things in some ways. But it also does kind of call to light that not only are people not patching, people aren't paying attention to what scans are hitting them. And people are apparently maybe possibly just unaware that they're even running a vulnerable device at the edge of their network. When you add that to what you were just saying, Aubrey, about the increase of 0 days, and I would just say that some of our research is showing an increase in sophistication in terms of a lot of attacker behavior, where it's not just go and download a crypto miner. It's multiple stages of malware, or it's the malware itself is not only running a crypto miner, but it's also brute forcing credentials, and it's also exfilling data, and it's blah, 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 all these things simultaneously. Or even some of the scams and fraud activity that we've seen, where it's not just you get a phishing email that if you click on the link, you get infected with some malware. You don't even click on a link. The attacker is going to actually try to develop a relationship with you over the course of weeks to increase your level of trust and eventually get you to the point where you will accept a Trojan PDF from them, no questions asked. I'm honestly a little bit worried right now if we've got that many unpatched FortiGates weeks after there was a lot of news about it, and then this increase in sophistication of attacker behavior. Things are not looking real bright, guys.
You raise an interesting point, actually, about like the number of how many of those 330,000 are real FortiGates and how many of them are honeypots looking like a real FortiGate. Because we saw that in the wake of CV 2022-1388, our own CV, right? People were reporting there was something like 16,000, pulling numbers largely from somewhere, but let's say it was 16,000 odd vulnerable big IPs on the internet, or big IPs with management ports exposed on the internet. And so we did a bunch of work to try and understand why that number was so big. And because this wasn't the first RCE we'd had in our management interface, and we figured that surely most would be no longer just sitting on the internet by this point. I think we worked out that the real number was much more likely to be around 3,000 or 4,000 than the 16,000 that was being reported. And the way we figured that out is there are an awful lot of big IPs, for the benefit of the audio podcast, that's in air quotes, that you can find with things like Shodan. But if you look at the HTTP response, they're all returning identical headers. And I mean identical down to the same JSession ID. So it's a canned response that is just coming out of some kind of honeypot system that is trying to look like a big IP. They've just captured a response from, a VM or whatever, and they just replays the same thing over and over again. We even saw IPs that if you hit them multiple times, just send them multiple gets with curl or whatever. You send them one get, it's a big IP. Send them another get, it's VMware ESXi. Same IP, same port, right? And it's just rolling through, now I'm this, now I'm this, now I'm this, now I'm this. So yeah, I do take those numbers with a pinch of salt, and I assume that the real number is potentially an order of magnitude smaller than Bishop Fox found. But I'm also pretty sure that there's a relatively large number of systems sitting on the internet, because we know that from our own experience. Attackers are getting significantly more sophisticated and putting in what seems like a lot more effort, certainly when there's high value targets at stake, right? Just look at the recent Outlook email compromise that happened. That, I am sure, was not trivial to pull off. Well, I say I'm sure. I really hope was not trivial to pull off, right? And there was probably and potentially an awful lot of collateral damage in terms of the number of mailboxes that were compromised in order to get at a specific target. That's burning a lot of bridges to carry out that attack. That's a seriously motivated, competent, advanced attacker. The future's bright.
So now, do you want to chat about Zenbleed for a little bit? I read through that, and it was a lot of that was, like you described, Malcolm, good conferences being like just outside of your comfort level, so that you have to up-level yourself a little bit. That's kind of how I felt reading that article. I was like, all right, I'm hanging on. Wait, I lost it. Okay, I'm hanging on. Ultimately, I got the gist of it. What were your thoughts on this?
Well, Tavis Ormandy is a noted and extremely talented and brilliant researcher. When I saw this tweet from him, I was like, oh, great. What's going on now? Especially since maybe a month or two ago, he had mentioned that he was moving over into researching CPU bugs, which is almost, in his case, a guarantee that there were going to be a bunch of CPU bugs coming out in a period of time. I really enjoyed it. I think the write-up that he did is fantastic. The takeaway is, because of the way that we built the overall ecosystem of computing, and there are lots of really good reasons why we did it this way, the way that the industry has done this is layers upon layers of abstraction, right? So if you're writing Python code, all you need to worry about is the code that you're writing. You don't necessarily need to worry about how the libraries are implemented. You don't need to worry about how the virtual machine that executes that operates. You don't need to worry about all of the layers underneath. You're implicitly trusting all those layers. And that's kind of necessary, because otherwise, if we were all hand coding ones and zeros to do anything, we wouldn't have come so far so quickly. Having said that, though, implementation does matter. And this is a really, really good example of it. The fact that essentially a very simple operation in C that's counting the length of a string with some compilers on some CPU architectures will cause the use of these extended registers, which then get involved with speculative execution, which then essentially ends up contributing to the bug. I don't really know what to say beyond that. It goes really, really deep.
It was astounding to me. I mean, like, one of the things that I thought was really cool about it was that they released this bug find to AMD, and they seemed to respond fairly quickly. But we just talked about FortiGate. This makes me think about is like, although AMD was able to respond real quickly and patch this vulnerability, those need to be implemented, those patches. And how do you get the patching schedule for that on critical resources? And it's so tricky. And what if that AMD is part of a cloud? I mean, and you have to rely on your cloud provider to maybe patch their AMD processors for you. To your point, it's scary. It is deep and scary.
So we talked about MSI, I think, in maybe last month's episode. I'm sure we've talked about MSI at some point. They lost their keys, right? And in order to revoke their keys, they need to push out BIOS updates to every impacted device, which is every device they make with the firmware they can upgrade. And we talked about how the problem there is that they don't have the mechanism for pushing updates out to users as easily as some large systems integrators, right? Like Dell and HP and IBM, who have a more walled ecosystem. The thing with this AMD update is it's updated microcode for the microprocessor, right? And so AMD fix it, then it has to go off to HP, Dell, IBM, all of those guys, to be packaged into something that can be pushed to the systems that they've integrated. And you are reliant on whoever produced the firmware the motherboard is running, basically. I am guessing that updates will come out, if they haven't already, very quickly for things like Dells and HPs and IBMs, right? But how long will it take for Asus, MSI, Gigabyte, the Far Eastern no-name stuff? It's not necessarily Chinese, but any of the stuff that isn't a major manufacturer that might not get, it may literally never filter down to those guys. It's an awesome write-up. You guys know me. I love a good hardware vulnerability. Even if you aren't like an assembly language programmer, it's really good at stepping you through how this vulnerability exists, how it operates. And like you say, Malcolm, it comes back to speculative execution again, like Spectrum Meltdown from several years back.
I know.
Right?
When I was reading the write-up, I was going along and I was like, oh, well, this seems fascinating. And then I got to that point, I was just like, oh, not again.
Yeah. Oh, look, there's a conditional jump. Here we go.
Yeah. And I guess full disclosure, at one point in my career, I actually worked for Intel. I was not involved with the design or anything like that of the processors. I was doing security work for them more at a corporate level, but I have a somewhat of a view into the way that processor manufacturers are hyper-focused on performance, right? Performance gains. And that absolutely makes sense. They are kind of the bedrock of performance on any given system. And the level of cleverness and engineering prowess that they bring to bear on that is astounding. Speculative execution is a brilliant idea, but also now a seemingly somewhat never-ending source of problems as well.
And I don't think this will be the last. Like you say, if Tavis is now going to concentrate on CPU problems, this probably won't be the last one that he'll uncover. He's really, really good at kicking over rocks and finding what's hidden underneath them. Like you said, if we didn't have the layers of abstraction, if we weren't writing software in languages that make prototyping rapid, and we didn't have virtual machines and drivers that take away the complexities of interacting with the hardware directly, we would not iterate anywhere near as fast. We would not have the advances we have either in corporate computing or in gaming or anything to do with computing.
Or telecommunications, or probably almost everything that we do every day. Our cars, our refrigerators, our
yeah, I mean, all of that stuff has probably an ARM chip sitting in it, right?
Yeah, to really make it totally encompassing here. We talked about abstraction from hardware to firmware to various levels of software, how that helps us move more efficiently and quickly, but is also the source often of bugs, of problems, of security issues, right? One could look at LLMs, especially when they're being used to write code or write configuration, as being yet another layer of abstraction. where you're not actually writing code. You're telling something to write code for you.
Yeah.
One had best hope that those LLMs are going in some way be made to perform that as well as a human programmer, hopefully even better, because otherwise we've just introduced a whole nother layer of places where things can go terribly wrong.
People have already shown that not only do LLMs occasionally hallucinate, right, and give you completely the wrong answer when you're asking them a natural language question, they can also give you completely the wrong code. And I know a lot of people talked about how this was a huge new risk of LLMs. But let's face it, Stack Overflow carries much of the same risks, right? Just a little slower, maybe, right? Because you have to wait for someone to answer you, an actual human on the other end, who may also make mistakes and or give you the wrong information or maliciously give you the wrong information. Whereas ChatGPT is instantaneous. You ask it a question and hope it gives you the right answer.
I worry less about experienced programmers using Copilot or other sorts of applications of LLMs to reduce the amount of typing that they do, essentially. But they're still going to be able to read the code and make sure that it's doing what they expect it to and so forth. What I worry more about is the use of LLMs in contexts where people who are not experienced programmers are able to generate something that eventually runs as code in a push to bring configurability out of IT and dev environments and into the general public, I guess, however that's defined, like within an organization, for example. There are a lot of really good advantages to that. There's been a lot of effort in sort of low code, no code development. There are economic advantages for companies that if they need to crank out 50 new mobile games a year, they're going to want to do that at scale and not having to pay a ton of money to do it. But in that context, there may not be the right balance of somebody actually sort of paying attention to where the car's going.
The race to the bottom in search of ever decreasing costs.
I think that if anything, this short period of time where we've had so much access to AI and it's been kind of all the rage, I guess, I'm a consumer of AI services. And one of the things that I've learned so far using it is you need human oversight. You have to have it. And so for me, the AI service that I consume the most is for audio. Occasionally I'll have a guest on a podcast or in a video with an interview whose audio is just atrocious for whatever reason. It's happened to me. I've used AI to improve myself. I've used AI to improve Aaron and a lot of other guests that we've had on this show. One of the things that I've found is that when the AI can't quite figure it out, it will replace it with just sounds. It's not a known language. It's just sort of like, I'll be talking to you and then and it means nothing. It spits garbage onto the video. So I can only assume, having done limited code runs, and I've used ChatGPT to try and write Terraform with me, and it's got mistakes. It happens. We know that. But again, oversight. I think there's always going to have to be human oversight for, well, maybe not always, but at least for now. Thanks for listening to This Month in Security. I'm Aubrey with DevCentral. If you like what you heard, don't forget to click like, subscribe, maybe even give a rating or a review. Tune in next month where we get some updates on OpenSSF and an interview with Steve Wilson on the OWASP Top 10 for Large Language Models.